Hello students, this is the problem that we have in hand. We need to write a program to find whether a given number is Armstrong number or not. An Armstrong number is a n-digit number which is equals to the sum of the nth power of its digits. So any single digit number is a Armstrong number because any single digit number, say 9 to the power 1 is equals to 9, right? If we take an example of a 3-digit number like 153, then the cube of each of its digits, that is 1 cube plus 5 cube plus 3 cube, is 153. So 153 is a Armstrong number. Now, given a number, the first thing is to determine how many digits does it have. So after determining the number of digits, we need to go for calculate that, say if the number of digits is n, then we'll have to calculate nth power of each of the digits of the number, then sum it up and then check whether this summation is equals to the given number or not. If it is equals to the given number, then the number is Armstrong number, otherwise it is not. So first thing that we would do is to get a number from the user and then first determine the number of digits in the given number. So for that we would be first declaring a variable and then we prompt the user to enter a number. And then read it by using scanf function. And then we'll have to write the logic to determine the number of digits in the number. So for that, what we would be doing is we would make use of integer division. So if any number is divided by 10, that is if we do an integer division, so the number itself is an integer, and if we divide it by 10 and if the result is 0, that means the number is of single digit. Say if the user enters 9 divided by 10, as it is an integer division for C compiler, so it would return a 0, and that tells us that the number entered by user is single digit. Now if the user enters a 2-digit number, if we divide it by 10, say the user entered 23, then if we divide it by 10, then we would get a non-zero number in return. So we would get 2 as the answer, as a result, which is non-zero. That's why we can say that that is not a single digit number. So for determining if by dividing by 10 if we don't get a 0, that means it is not a single digit number, then we would increment our division by 200. So now if we see that a number if divided by 100 is giving us a 0 as result, then the number should be a 2-digit number. Similarly, if after dividing by 100, if it returns a non-zero, that means it is not a 2-digit number, then we would divide by 1000. Like that, we would go on till we get a division dividing by which we get a result 0. And by that, we would be able to determine the number of digits in the given number. So let us start with the division 10. So let me declare a variable div and initialize it with 10, while, so we'll have to determine how many digits that the number has. So let me declare another variable number of digits, and initialize it with 1. Now if num divided by divisor is non-zero, then what we are going to do is we are going to increment the num of digits by 1, and also the current value of divisor would be multiplied by 10. So this is our logic to determine the number of digits in a given number. Let us check how would it work. Let's say if the user enters a single digit number, say 9, the current divisor is 10. Initial value of divisor is 10 and number of digits has 1. So 9 divided by 10, as it is integer division, because numerator and denominator both are integers, so it would return 0 and this condition would become false. So after this loop, whatever is the value of num of digits, this variable, this would give us the number of digits in the number. So indeed, for a single digit number, the num of digits would contain 1 when the control comes out of the while loop. What about a two-digit number? So if the user enters a two-digit number, the initial division, say 23 is entered by the user, 23 divided by the initial value of div is 10, 23 divided by 10 would return a value 2, that is not equals to 0, so this would be satisfied. Number of digits, this variable would be incremented to 2, and I've forgotten to write equals to here. So, and the divisor would be incremented by multiplied by 10, right? So the divisor would become 100 now. So in the next loop, 23 divided by 100 would return us a 0 because it is an integer division, and this condition would become false. So the control would come out of the loop, and the num of digits now contains 2, that is the number of digits in the user entered value. Right, so this is the way that we would determine the number of digits in the given number. So after determining number of digits, now we'll have to calculate digits of the summation of the digits to the power num of digits, and then we'll have to check whether that summation is equals to the number given number or not. So for that, we'll be writing another loop. So our logic is to get the digits one by one from the given number, and then calculate the power of that digit to this number, that is number of digits, and then add it up in a summation variable. Accumulate that in a summation variable, and after the loop, that we would try to equate the summation variable with the initial number given by the user, and if it is equal, then we would print that it is an Armstrong number, otherwise we would print it is not an Armstrong number. So that is our algorithm, and for that what we would do is we would start with temporary variable. We want to keep the initial value of this number variable stored in a temporary variable. We would utilize this for comparison with the summation of the power of the digits. Now, the loop you will be using here is while loop. We would fill this condition later on. Let us first try to see what would be there in the inside the while loop. So first of all, we need to get the digits out of the number. So for that, we will be using a mod operator. So as you might be knowing that modding any number with 10 returns as the least significant digit. So that is what we would extract out of the number, and that extracted number we can keep it in a separate variable, say digit, so digit is equals to num mod 10. This is going to give us the least significant digit of the number. And now we'll have to calculate this digit to the power num of digits. So that is what our purpose is, target is. So for that, what we can do is we can use another loop to calculate the power of the digit when raised to number of digits. So digit to the power num of digits would be calculated like this. We take a for loop, and we would take a variable mult in which we want to keep the result of digit to the power num of digits, right? And we would initialize with 1. Now also we would declare a loop variable. So here I equals to 1 to I less than equals to num of digits. So how are we going to calculate the power of digit to the power num of digits? So this value would be calculated by iteratively multiplying the value of digit into mult into this variable, right? So the statement would be like this: mult equals to mult into digit. Now let us check whether our conditions are correct or not. Say the number of digits contains 4, right? So the digit contains a 2. So we want to calculate digit to the power 2 to the power 4. So let us check whether this should be able to give us the expected result or not. So mult initially contains 1, right? Mult initially contains 1. Now 1 into 2, at the first iteration when I is equals to 1, 1 into 2 is 2. So 2 gets stored in mult, and then I becomes 2. 2 into 2, 4. So 4 gets stored in mult, then I becomes 3. Then 4 into 2 becomes 8, mult becomes 8, then I equals to 4, 8 into 2, 16, that gets assigned to mult, and after that I becomes 5, and the controls comes out of the loop. So after this loop, the result of 2 to the power 4 is contained in mult, right? So this we want to accumulate in a summation variable. We want to calculate the power of each of the digits, and then we want to accumulate it in a summation variable. So for that we would declare a summation variable as well, and we would initialize it with 0. So see the difference: a multiplication variable accumulator variable would always be initialized with 1, whereas a summation accumulator variable would be initialized with a 0. So here we would write this statement: sum equals to sum plus mult. Now mult contains the digit to the power number of digit, and that we are accumulating in summation variable. So initially we would get the least significant digit of the given number. We would raise it to the power of num of digit, and then we would accumulate it in the summation variable. Initial value of sum is 0, so 0 plus digit to the power num of digit, that would be accumulated in sum. So now one thing we missed here is to set the value of mult to 1. Why are we doing that is that every time power would be calculated and its result is stored in mult, we don't want to affect the next digit's power, right? So before this going into this loop, we would initialize it with 1. Now after we have already calculated the power of the least significant digit of number, what we can do is we can just throw that digit away because we are done with it. So for that we would be using this integer division by 10. So what this would do is it would throw away the least significant digit of the number and store the remaining digits into the num variable back. So if the user has entered 153, then 3 would be thrown away and then 15 would be stored back in the number. So this loop would go on till the num variable becomes 0. So until and unless the num variable becomes 0, we have some digits left in num. So we would keep on processing those digits and taking their powers and adding it up to the sum variable. And as soon as num variable has become 0, that means there are no more digits remaining in the number, and so we would come out of the loop. And after coming out of the loop, the summation variable contains the power of all of the digits of the given number. Now to check whether it is Armstrong number or not, we'll have to see that the value of the number entered by user is equals to this value of the summation variable or not. So for that we can provide a if statement. So as you see, we have already modified the value of num variable and it has now become 0, and so it has come out of the loop. So we would not be able to use the num variable here for checking purpose. That's why the initial value of the number variable was stored by me into this temporary variable. So that is the value that we would be comparing this summation value with. So temp is equals to sum. If this condition is satisfied, then we can say that the number is Armstrong number. The number person D is an Armstrong number. Initial value, the number is stored in temp. Else we can write the number is not an Armstrong number. Right. So with that we have finished our code. Let us now build it and check whether it is working fine or not. So a famous Armstrong number is 153. So let us check whether it is coming out to be correct or not. So the number 153 is an Armstrong number. So our program is working correct for the positive cases. Let us check any negative case. Say 147. The number 147 is not an Armstrong number. And one more positive case, let us check for a single digit number. So as you know, the single digit number is always an Armstrong number. So let us check with 9. The number 9 is an Armstrong number. So our program is working correctly for all the 3 inputs that we have given. So it is, in general, it is correct program. Now the number 9 is an Armstrong number because 9 to the power 1, because it has got a single digit. 9 to the power 1 is always 9. So this is Armstrong number and our program is able to find it. So with that we have finished with this program. Thank you for watching. Bye.